Well, good morning or afternoon or whenever it is you're viewing this. This is the next lecture on solving rational equations. And this is one of those sections where I'm going to show you the method. The method's never going to change, but we're going to do several different problems. And before we do this, though, we need to realize that, and I've talked about this just recently, there's a difference in expressions and equations. Notice, expressions, you'll have all the stuff, but you don't have an equal sign. There's not anything on the other side. Okay, and with these, we're really just simplifying. All right. Now, equations are different. We haven't done rational equations yet. Rational equations, you see we've got stuff on both sides of the equal sign. That's how we can tell the difference. And we are trying to find the value of x. So we're back to solving equations, and this is, okay? And this is what we're going to be dealing with today. We're going to start with things like this, and we're going to try to find the value of x. One thing to remember that idea of restrictions on the variable in a denominator. If we get any solution that we plug it in here and get a 0 in the denominator, we have to throw that out. So that's the idea, again, of a restriction. All right, so let's kind of look at what this would look like. So just going to leave that up for a minute. Let's start with one that's really simple. Negative 7 over w is equal to 8. So here's the idea, and here's what we're going to do in these problems. We're going to take whatever different denominators we have, and we're going to multiply everything by that. Really, we're finding a least common denominator, but we don't have to think about it in those terms. We're just going to take whatever denominators we have, multiply every term by everything, and it'll be a little clearer what I mean by that when we do a few problems, and then that's going to get rid of our denominators. So for instance, in this problem, the only denominator we have is w. So I'm going to say negative 7 over w, multiply that by w. That's equal to 8. Now what I multiply on one side, I also have to multiply on the other. So I've multiplied everything by w. All right, negative 7 over w times w. Remember, this is kind of like w over 1, but we don't usually write the over 1 part, but we can think about it that way. So then these w's cross out, because just like with simplifying and multiplying, right? We have the same term on top and bottom, so we can cross those out. And we're left with negative 7 equals 8w. All right, now this problem right here, negative 7 equals 8w. This is a plain old equation. So all we've really got to do here is divide by 8, and we're through. Or are we? All right, so negative 7/8 is equal to w. Now, the reason I said or are we is we need to remember that when we're doing these problems especially, we need to always check to see if plugging this answer into our original equation is going to cause a 0 in the denominator. Now, this is a fraction, and it may throw you off, but if we put negative 7/8 in for w right there, we're not going to get 0. Let me show you what that means. If I were to plug that in, I would get negative 7 over negative 7/8. All right, equals 8. There's not a 0 on the bottom here, so we're okay. It's easier to see what I'm talking about when we have one that does have a 0, and we'll get to one of those clean enough, or soon enough. So once we get our answers, we always need to check our answers. I checked this one, and that's okay. Now, that's the basic idea that we're going to do in every one of these problems. We're going to make the denominators as simple as possible. Sometimes we'll have to factor. And then whatever factors we have, we're going to just multiply by that, okay? -5. So -5 is equal to 3 over x minus 1. And let me make one -3. All right, -5 is equal to -3 over x minus 1. Again, the only denominator I have is x minus 1. So I'm going to multiply both sides by that. All right, again, these are going to cross out. That's kind of what I'm doing. The reason I'm multiplying is to cancel those out. So now let's look at what's left. I have -5 times x. I'm going to distribute over here. -5x. -5 times -1, that's +5, equals -3. All right. And now it's just a linear equation like we've done 100 times. We're just going to solve this the way we've always done. We're going to subtract 5. Minus 5x is going to equal -8. We're going to divide by -5. And x equals 8 over 5. All right. And again, we've done the work. I'm going to plug this in. Is 8 over 5. 8 over 5, if I put it right in here and subtract 1, am I going to get 0? No. In fact, I'm going to get 3/5. But all I really have to know is it's not 0, and that tells me that that's my answer. All right, so now we've got the basic idea. Let's start expanding on this, and let's make things let's start making them a little more complex. Now, this is the first problem we've done that has two denominators. And that's okay, because in this problem, they're both the same. So since we have x minus 3 over there and x minus 3 over there, if we multiply everything by x minus 3, that's going to work out for us. So we're going to have x over x minus 3 times x minus 3 minus 5 times x minus 3. And that's going to equal 3 over x minus 3. And let me just clear this out. Times x minus 3. Okay, so notice, I looked at the denominator. I had one denominator. Well, I had two denominators, but I had the same one. So I multiplied everything by x minus 3. X minus 3's cancel. X minus 3's cancel. And at this point, we're just going to go with what's left. This is x minus, all right, minus 5 times x, that's minus 5x. Minus 5 times minus 3, that's plus 15, is equal to 3. All right, so now we've done the first part of these rational equations is always trying to get rid of the fractions, and then we're going to turn it into something that we know how to work. This is a linear equation. We know how to work these. So I'm going to combine the like terms. I have x minus 5x. All right, remember they're on the same side, so we just kind of subtract them like this, 1 minus 5. I'm going to move the 15 to the other side, so I'm going to subtract 15 minus 4x equals negative 12. Divide by negative 4. And at the very end, negative 12 divided by negative 4 is 3. And I'm sorry, I got to the bottom and got a little sloppy. But, okay. We found that our answer is 3. And we're done. No, we're not. Remember that with these rational equations, we always have to check to see if it causes any problems in the denominator. So, for instance, if I take this 3 and plug it in right here, if I plug that in place of x, instead of x minus 3, I'm going to have 3 minus 3. 3 minus 3 is 0. All right, so this solution causes a 0 in the denominator. We've always got to check for that in these rational equations. And if that happens, we have to cross it out. We have to throw it out. All right, so here's the deal. We did all this work. We found one possible solution. That solution did not work. So in this case, we're going to say the answer to this problem is no solution. Okay. All right, so let's just kind of walk back through this. Again, we're looking at our denominators. And we want every different denominator, we're going to multiply every term by that. And so far, we've just had one denominator. We will get to some later that have different denominators. But for right now, we're just working these. We multiplied everything by x minus 3, even the things that did not have a fraction. Our fractions canceled. We worked out this linear equation and got 3 for our answer. 3 causes a denominator to be 0, so we have to throw it out. That was our restriction. The thing about doing these video lectures is so often I actually stop and I'm about to ask, are there any questions? And you can't answer me, so. And if you know, I may have actually done it. I don't know. All right, we're going to continue with these where we just have the single denominator term, and then we're going to do one more of those, and then we'll probably change to do something else. All right. Again, there's only one denominator in the problem. These are easy to figure out. If there's just the single variable, we know what to multiply by. So in this problem, I'm going to multiply everything by y. So I have y multiplied by y. I have negative 11 times y equal to negative 9 times y plus 24 over y times y. We multiplied everything by y because we want these to cancel out. So we've gotten rid of all of our fractions. Now we can try to work the problem. Y times y is y squared. Okay, remember when we're multiplying them, the power changes. When we're adding them, the number out front changes. Minus 11 times y, that's minus 11y. Negative 9 times y, that's negative 9y. Plus 24. All right, and we can see this problem's a little different. Because in every other problem, we've never gotten a square on our variable. Here we have y squared, which means this is a quadratic. And the only way we have solved quadratic so far is to get everything on one side or the other and then factor it. So what I'm going to do is I'm going to take this 9y and this 24, and I'm going to move them both over to the other side. Now, how do we move the 9y over? Well, we add the 9y. Now, just for space's sake, I'm going to go ahead and move this over in the same step. And we've done that before, so subtract the 24. And I'm just going to write it over here somewhere, just to kind of remind us that's what's going on. All right, so these cancel out, and I get 0. All right. All right, minus 24 plus y squared. And then minus 11 plus 9, that's going to be minus 2y. Okay, everything's on one side. I'm going to reorder that just a little bit. Y squared minus 2y minus 24 equals 0. And I could have written it like that to begin with. I didn't have to write it in this order. I just did. So now I want to try to factor this. That's how we've solved it. I need to multiply to negative 24. I need those same two numbers that multiplied to negative 24. I need them to add to negative 2, which means the bigger one has to be negative. All right, we had a difference. These were different, so we had a difference. We're going to be subtracting. And look here, we've got it factored. And we learned a long time ago that what we're going to do is we're going to set both of these equal to 0. We're going to solve them. Sorry, I don't need an equal there. Plus 6. Y equals 6. In this other equation, I'm going to subtract 4. And y equals negative 4. All right, so this time we got two answers. Well, which one of them do we need, or both of them? All right, we're going to check. And we're going to check, do either one of these cause a 0 in the denominator? If I plug 6 in for y right there, I just get 6. If I plug negative 4 in for y, I get negative 4. Neither of those is going to give us 0. So in this problem, I get two answers, and both of those are answers, 6 and negative 4. All right, so let's leave this behind. Let's look at something that works a little differently. Well, actually, it doesn't really work differently as much as it's just a little more complicated. Okay, here we go. For the first time in one of these problems, we have different denominators going on. And that's not a big deal. But here's how I want you to think about this right here. This 6x, I want you to think of that as 6 times x, because that's what it is. So now, here's the deal. We're about to multiply everything in this problem by something, all right? All right, so what I'm going to do is I'm going to take every different denominator and multiply by it. So for instance, I'm going to multiply by 6. I'm going to multiply by x. I'm going to multiply by 4. And then I've got x. Well, x is already there, so I don't have to do it again. You see what I did there? Every different factor is right there. And I'm going to do that for every term. So minus 5 over 4, and I'm going to multiply 6 times x times 4 equals 1 over x times 6 times x times 4. All right, and it may seem like I'm doing a lot of writing here, and I guess I am, but a lot of this is fixing to clear up. For instance, over here on the right, these x's are going to cross out. In here, the 4's will cross out. And in this first term, the 6 is gone and the x is gone. All right, so let's see what we have left. I have x plus 3 times 4 minus, okay, I have 5 times 6 times x. That's 30x. And over here, I have 1 times 6 times 4. That's 24. All right, so we're going to look at all the different factors in these denominators. We multiply every term by all of the different ones, and everything should clear out. And in this case, we're left with a nice linear equation that we know how to solve. We're going to distribute the 4x plus 12 minus 30x equals 24. Okay, I'm going to do a couple of things here. I'm going to go ahead and move the 12 over. I'm going to subtract 12 on both sides. All right, and then I have 4x minus 30x. That's minus 26x equals 12. I seem to be running out of space, so let's just move up here. I'm going to rewrite that line. Minus 26x equals 12. Divide by negative 26. And so x is negative 12 over 26. And then if I wanted to try to simplify that, I can divide the top and the bottom by 2. So that's going to be negative 6 over 13. All right, so yes, there's a little ugliness here. There was a lot of writing. But once we got rid of all the fractions, it's really a simple linear equation here. Excuse me. The last thing we need to do, remember always, is to check for zeros in the denominator. If I take this negative 6 over 13 and plug it in here, 6 times negative 6 over 13, well, it's not 0. And if I plug it in there, obviously I'm not going to get 0. So this one's good. Now, you might be wondering why we got 2 answers in the last problem, and in this one we only got 1. It's because in the last problem, when we multiplied everything out, we ended up with a y squared. Here we didn't have anything squared. We just had x to the first power and x to the first power. So if everything is to the first power, it's going to be a linear equation. We solve those by getting variables on one side, numbers on the other. If we get x squared or y squared or whatever our variable is, then we're going to get everything on one side and factor it. All right, got 2 more examples for today. Still solving rational equations, still doing the exact same thing we've been doing, but just with a little different look. So 8 over 4w minus 8 minus 1 equals 2 over w minus 2. All right, for the very first time, we're having to do something a little different. All right, and you might look at this and say, well, I'm just going to multiply by 4w minus 8 and w minus 2, and you could do that and you would get the right answer, but it would be a little more complicated than it had to be. And let me show you why. Let's look at this first thing right here. This is actually 8. And if we look at 4w minus 8, we can factor that a little bit. We can pull this 4 out of it. That'd be 4 times w minus 2. All right, now I'm going to leave a little space here because I'm going to try to save just a little bit of board space. All right. So now what are my different factors in the denominator? Well, they're 4 and w minus 2. That takes care of everything. I have a 4, I have a w minus 2. Over here I have another w minus 2. So I'm going to multiply everything by 4 and w minus 2. Things that will cross out. It'll be nice. Okay. Over here, the 4's cancel out and the w minus 2's cancel out, and we're left with 8. All right. Then we have minus 1 times 4 times w minus 2. All right. This is where we have to be careful because of this minus. I'm trying to think how I want to do that. Look. 4 times w minus 2 is 4w minus 8. And the reason I put this in parentheses is because we're subtracting. That subtraction has to distribute over everything. So just for right now, I said minus, and then I said 1 times 4 times w minus 2. That's where the 4w minus 8 came from. All right, over here on the right side, 2 times 4, that's 8. All right, this is a lot simpler than what we started with. So let's just kind of look at this. This is 8 minus 4w. The minus distributes. This becomes plus 8 equals 8. A lot of 8's in this problem. On the same side, we have 8 plus 8. So this is negative 4w plus 16 equals 8. Negative 4w plus 16 equals 8. Just rewriting that last line. So I'm going to subtract 16 on both sides. Negative 4w equals 8 minus 16 is negative 8. And finally, when we divide by negative 4, w equals 2. Whew. I feel tired. But it actually wasn't that bad. I'm kind of overreacting, aren't I? So we did all of this to get to this point where we have w equals 2. The very last thing we always have to do is check for zeros. If we take this 2, and for instance, we plug it in right there, we get 2 minus 2, which is 0. We have to throw this out. I'm going to just write out here, causes a 0. So in this problem, we did all of that work. We found one possible solution of w equals 2, but it causes a 0. So in this case, we say there's no solution. All right, remember, you've got to check it. Because, and there'll be problems on your homework and probably on a test where this is what happens. It works perfectly. You get a nice whole number answer, which actually makes us feel pretty good. And then it causes a 0. That's not as much fun. All right, and if you don't check for that causing a 0, you're going to get it wrong. And you would have done most of the work correctly. All right, last problem for today. Or for this lesson anyway. Just to save a little bit of board space, it's not that it's that long, I'm just trying to avoid crossing over. Okay. So we've got x over x minus 6, 24, or minus 24 over x squared minus 36 equals 2 over x plus 6. This is a pretty standard type problem. All right, again, the first thing we want to do is factor any denominators. All right. So I need to do something with x squared minus 36. Now, again, I know that I'm about to be multiplying all of this stuff by something, and I'm trying to save a little board space, so I'm going to leave a little space here. I'm going to say minus 24 over. Okay, and now I want to factor x squared minus 36. This is really nice. This is a difference of squares. Difference of squares has the plus and the minus. Okay? Square root of x squared is x. Square root of 36 is 6. And we're done. Again, I'm leaving space. Equals 2 over x plus 6. Whew, I'm using up a lot of board space. I'm probably going to regret that in just a minute. Okay, so now, remember, once we get everything factored, what we want to do is we want to take all of the different factors on the bottom and multiply by those. So for instance, I need to multiply everything by x minus 6. Looking over here, I have x plus 6. That's different. X minus 6 is already there. X plus 6 is already there. So I'm multiplying everything by x minus 6, x plus 6. Okay. So a bunch of stuff should cancel out. The x minus 6's cancel out. The x plus 6's cancel out. Those x minus 6's cancel out. These x plus 6's cancel out. And so all of our denominators canceled out. That's what we wanted. So now let's see what's left. I have x times x plus 6 minus 24. Okay, that's nice. And over here, I have 2 times x minus 6. So we factored, we multiplied everything, and we cleared all those fractions out, and we're left with something that looks maybe a little simpler. Now we're just going to distribute and work our way through. X times x plus 6, this is x squared plus 6x. Then the minus 24 is hanging on out there. All right, on the right-hand side, 2 times x is 2x minus 6, so this would be 2x minus 12. And I see that, again, we get this x squared here. Now, when I see that x squared, that lets me know I've got to get everything on one side and factor. So to move this 2x over, I'm going to subtract 2x. I'm going to go ahead and move this at the same time. I'm going to add 12. So all of this cancels out, and I have equal to 0, which is what I like to have. And then I'm going to have x squared plus 4x minus 12 equals 0. Okay. So we've done a lot of work. We've gotten down to a quadratic. And what we're going to try to do is factor that quadratic. So I need to multiply to negative 12, but add to 4. Oh, 6 and 2, yeah. In fact, positive 6, negative 2. For just a second, I thought I had done it wrong. All right? Because look at that. 6 times negative 2 gives us negative 12. If I say 6 plus negative 2, I get positive 4. All right. That marker seems to be drying out a little bit. So now, what do we do from here? Same idea. X plus 6 equals 0. And then x minus 2 equals 0. We set each factor equal to 0 and solve. So I'm going to subtract 6. X is negative 6. Then I'm going to add 2. X equals 2. And I get 2 answers. And I have to check both of these in the denominators. I have to. Let's do 2 first. 2 minus 6 is negative 4. That's not 0. 2 squared is 4 minus 36 is not 0. 2 plus 6 is not 0. So that one doesn't cause any zeros. We're good to go. Negative 6, let's just start here. Negative 6 plus 6, it causes a 0. We have to throw that one out. And so in this problem, that is the only answer. Okay, and so with these quadratics, it's possible that we might get two answers and both of them work. We had that earlier. You might get two answers and only one of them works. In fact, it's even possible to get a quadratic where you get two answers and neither one of them works and it'd be no solution. That's why we have to check them. We have to know for sure. All right. So, just to sum up, when we're dealing with a rational equation, and it's an equation because we have things on both sides of an equal sign, and also our directions will say solve instead of simplify. All right, we're dealing with an equation. What we're going to do is factor any denominators we can. Then we're going to take every different factor in the denominator. All right, the only different ones we had x minus 6 and we had x plus 6. And then those same two repeated. We multiplied everything by those. That should get rid of our fractions. And then we solve from there. And it'll either be a quadratic where we have to factor it and then solve, or it'll just be a plain linear equation where we just solve the equation. All right. And so that is solving rational equations. The basic process doesn't change. The problems are a little different. When you get to this step, you've got to notice that this is a quadratic and you've got to know what to do with that. In the problem just before this one, when we got to that point, we didn't have any x squared. We just had x. It's linear. What do we do with linear? We get variables on one side and numbers on the other. So that's the end of this lesson. Until next time.